I'm Kainton, the Tech Pro, and today we are going to be talking about question 11 and 20 on our data science question and answer series. And today's question is going to be question 11 that says, what is multiple linear regression? So this is a question we are going to be answering today. I'm going to also like to remind you to subscribe to my channel if you've not subscribed. So just click on the subscribe button below so that when I make better videos or make an improvement, you get updates immediately. Now you can also find question 1 to 10 in this place. So basically this is for you to understand the concept and be able to explain it in your own words using minimal diagrams and notations. Alright, so the first thing I normally do when I explain concept is start from known to the unknown. And that is one thing you should always do. It's a very good way of learning. Start from known to the unknown. If you're always able to relate what you know to what you don't know, learning becomes a lot easier. So the first thing we are going to talk about, of course, we know what we know in this case. We know about linear regression where we have x, y, and we have values in this place, xp. So we have y1, y2, y3, y4, all the way to yp. So in this case, we are trying to find the relationship between x and y, and in this case, we assume a linear relationship. Sometimes, some textbooks you might see something like this: f of x equal to beta 0 plus beta 1 x. Sometimes you may also see f of x and omega is equal to omega 0 plus omega 1, or w1 x 1 plus w2. Okay, let's stop at omega 0 plus omega 1 x. So sometimes you see any of these. Both of them are the same. Now when we are talking about multiple linear regression, we are talking about where the target variable or dependent variable is a linear function of multiple predictor or independent variables. So in this case, we are talking about a table like this. So we have x1, x2, x3, all the way to xp. So we have p predictor variables. So the question is, how do we relate the two? One thing you can do is to use several linear regression models. For instance, you can go by doing a linear regression of this is y into x1 to do the linear regression model, and then do another linear regression model x2 y. So in this case, you actually have not done multiple linear regression. So you are still doing simple linear regression in this case, and you are simply doing pairwise plots of the predictor variables to the target variable. So I'm going to simply write the equation for the multiple linear regression model so that you have it in mind. So for the multiple linear regression model, you have a function of x equals beta 0 plus beta 1 x1 plus beta 2 x2 plus plus beta p xp plus some error, right? So this is basically what multiple linear regression is all about. And I've actually written it here. You can see, for example, given the variables, predictor variables, or the independent variables x1, x2, all the way to xk, we seek to model the relationship given in this way. So in this, the benefit of this is that when you consider it this way, you can now see the effect of one of these variables to the output in consideration to the other variables. So you are not assuming this time that x2, x1 x2, so they are not, this one is not constant, so you are looking at relationship between x1 and y, given that also in consideration with the relationship between x2 and y. So it's not a situation where you have x2 as constant and you are looking at this separately. No. So I'm going to stop here. I hope you can explain this in your own words at this time. And in the next step, in the next question, question 12, we are going to look at three terminologies or three terms, which is forward selection, backward elimination, and stepwise selection in case of model building. I'm going to thank you for viewing, and also remember to subscribe to my channel if you have not subscribed.